All right, Katie, I'm going to do the last two. And these are harder problems, I would say. But I'm going to try to do them rather quickly. I think it was problems 41 and 47. 41 said that the baseball was going at 33.6 meters per second. They gave us three different scenarios at 30 degrees, 45 degrees, and 60 degrees. I'm going to kind of contemplate all three of those, but not that much. You've got to fill in the details. Just to simplify our interaction. So let's think about at 30 degrees. Ooh, that's not a very straight line. At 30 degrees, that thing, it's going, the magnitude of the velocity is 33.6. And I can say this, if I'm interested in how fast it's going in the y direction, the velocity in the y direction initially, that's what I'm interested in. And, well, that's really v sub y o. This is my initial velocity, and that's my initial velocity in the y direction. And that's equal to, well, let's do it this way. Sine of 30 degrees, if that's the first one I'm going to contemplate, is equal to my opposite side, VYO, over 33.6. And I can solve that for my initial y velocity by saying 33, multiplying both sides by 33.6. 33.6 times the sine of 30 degrees equals v sub y o. Likewise, I'm going to go ahead and do it at the same time. My velocity in the x direction is going to be 33.6 cosine 30 degrees equals my initial velocity in the x direction. By the way, just to continue this, I'll say that's not going to change because there's nothing affecting it. So that's constant. So that's my velocity in the x direction. All right. You should know, and I'm going to write this as a fact. I could derive it, but I don't think I need to or want to tonight. I could say that we have these equations, and this is one you've seen before, that h, for example, this is in the y direction, equals h sub o plus my initial y velocity times t plus 1/2 my acceleration, I guess I'll put in the y direction, t squared. That's a familiar equation that pops up again and again and again, so you should know that. In this case, h sub o equals 0. This is a baseball getting hit off a bat, and my initial y velocity equals 0. So this equation reduces to h equals 1/2. Well, I'm sorry. My initial y velocity is not equal to 0. it's equal to 33.6 times the sine of 30 degrees. I'm going to go ahead and not be an idiot and say that sine of 30 degrees equals 1/2. And so h sub v0 equals 16.8. So my height, I'm going to rewrite this. The height of the baseball at any given moment, h sub 0 equals 0. This quantity equals 16.8 times t. A is equal to negative 9.8. So I can rewrite this as 16.8 times t minus 4.9, which is 1/2 of 9.8. T squared. Now we're asked two questions here. One of the questions is, what's the maximum height? And a second question is, how far does it travel before it hits the ground? All right, we're going to answer both of those questions. The maximum height that's the y-coordinate of the vertex. Maybe there's another way to do this. I'm doing this in the simplest way I can think of, which is I want to find the x-coordinate of the vertex, and that's equal to negative b over 2a, because this is a quadratic equation, and that's how we find the x. That is one way we can find the x-coordinate of the vertex of a quadratic equation, is that it's equal to negative b over 2a, where 16.8 is my b, that's my middle term, and negative 4.9 is a. So I get that that is equal to negative 16.8. That's my b coefficient, over 2 times negative 4.9, and that's negative 9.8. It's really not x, it's t. And so I can say that t equals the time that it takes to hit the maximum height is 16.8 over 9.8. That's going to be around what? It's going to be around 1.7, roughly speaking. And then I plug that in to find my height using this equation. So my height in general is this. When I plug in 1.7, I'll find the maximum height of the baseball. I'm going to say I've adequately addressed that issue of what the maximum height is. Now we're going to go to figuring out what the distance the ball traveled was. All right, Katie. So now we have, you can go back to some of those equations if you want to, flipping back and forth. But we want to know what the distance it traveled was. As I said to you today, this baseball is basically doing this. So when we find out how far it's gone in the x direction, that implies that h equals 0. So now I have to think about what that huge equation was. H equals h sub o plus my initial velocity, which was 33.6. Now I'm talking in the x direction. Well, we don't really need to have written that. All right, we need to say that it was... No, we don't need any of that. I'm being stupid. I'll write out the whole thing, but a lot of this is going to cancel. My distance in the x direction is equal to how far... Well, there's no... I'm not going to do it in a stupid way. I'm just going to say it straight out. I'm going to say my velocity in the x direction is constant. So that's not changing. And the only thing that's making it, the only thing I need to compute in the x direction is how long it took to fall. Well, and I can be smart about this. We already found this time, and that time was t equaled, I think if I'm right, it was about 1.7 seconds. That was from the previous problem. And that was how long it took to reach its highest point up there. But parabolas are symmetric, so that means it must have taken, to get to there, it must have taken about 3.4 seconds. There are other ways to figure this out, but the easiest way is to say that would be 3.4 seconds. And v sub x is going to be, we did this, was it 3.36 or 3.64? Maybe it was 3.64. Doesn't matter. Whatever the original velocity was, I think it was 3.36. Whatever that was, the magnitude of the original velocity, we would multiply that by cosine of 30 degrees to get the velocity in the x direction. And then to find the distance that it traveled in the x direction, we would just multiply that number times 1.7